Hello, class. I just wanted to answer a couple of questions that I've had from different people about this lab that I wanted you guys to do, this virtual lab. I thought this would be kind of fun and a cool way to kind of see how what we've been learning will work if we do it in this simulation. So the first thing we do is we open up this link I have here, and it takes us to our intro page. So we're not going to do lab. We're going to click on intro right here. And now this is our blank page. So that was our first step. Our second step says create a series circuit with one battery, two light bulbs, and one switch and wires connecting them all. Remember that a series circuit has only one loop. So we're going to try to make something that looks just like this. So the way we do that is we click on this battery, we drag it out here. We're going to need two light bulbs, 1, 2, and a switch. And then the rest is going to be just these wires. So if we connect them at the circles here, we're going to take this wire, connect it here, up to this one, and then another wire there. So if I close it, we can see our lights are on and it's happy. So right now I'm going to leave it open. So that was our first step, is to make something that looks just like our picture here. Now, step 3, it says click on the battery and set the voltage to 20 volts. And we see our picture here is highlighted, and we can see we can change the voltage. So what we do here is we click on the battery, and this one right now is at 9 volts. So if I use this arrow to go up to 20, that's what I want us to do. So we're going to go all the way up to 20. So we can either use the arrow or we can slide it. This sliding is a little bit easier, so we get to 20. So that was step number 3. Step number 4. I'm going to click on one of the lights, it doesn't matter which one, either one, and change the resistance to 20. So let's click on our light, and now we can change our resistance to 20. So down here I said change to 20 after clicking on our light. Alright, step 5. Now I want us to close the switch so that electricity can flow through, and then we're going to measure the current using our ammeter. It can be found on the far right. So we can see over here our ammeter looks just like this. I pulled it over like that. So I pulled my ammeter over. Oh, I need to close my switch. We can see things are nice and bright. And now using this end of the ammeter, I can measure the. So this says, using your ammeter, what is the current? Well, I just reach it over, see if it's the same or if it's different, and test it that way. We can see when I put my ammeter over the wire, it has a current. So I just type that in for question 1. Now question 2 says, using Ohm's law, what is the total resistance in your circuit? So remember, you already know the voltage and you just found the current. So we want to use that R is equal to V divided by I. So we want to find the resistance using Ohm's law. So we just found that our voltage, or we put our voltage at 20, and we have a current from above. So we know that this will be 20 volts because we set it, we put it to 20, and then we should put in our current, whatever it is, and I gave you the equation right here. I already gave you your equation to use to find our resistance using Ohm's law. Now, I want you for question 3 to find our total resistance using in a series circuit using our equation here, that R total is equal to R1 plus R2 in the circuit. So I should have probably added that R1 is equal to something and that R2 is equal to something like this. And we can find what R1 and R2 are equal to by clicking on our light bulbs. So if we look at our light bulbs, this light bulb is at 20 ohms resistance, so R1 is 20, and we can say R2 is going to be 10 ohms of resistance. So I probably should have helped you guys out a little bit more. So this should be 20 ohms, and this should be 10. So using our equation now, if we wanted to do it as we usually do, I should have wrote given. We could write equation. We're going to say R total is equal to R1 plus R2. And then we can do our work. So, of course, we can easily do this one. 20 plus 10 is 30. Now, This last question says, in question 2, right here, in question 3, you found the total resistance using 2 different ways. We used Ohm's law, and we used our equation for a series circuit. And did you get the same answer? Should they be the same answer? Why or why not? So I just want you to think about it and do it that way. So now, if we wanted to, we can erase our by clicking on this little reset thing here, this little undo. So we can either do it that way, or we can leave it and just make another circuit over to the right. So I'm just going to make another circuit over to the right. So later I can use it to compare. But this says, even in our steps, to clear our drawing so that we can start fresh. So whichever one you want to do. Then we're going to create another circuit, but that looks like this. We're still going to have 2 lights. We're going to have a battery and a switch. So we have all the same things, but just in a different setup now. So if I do it this way, I'm going to grab my battery, I'm going to grab a light, another light, and a switch. And I always like putting the switches right on the battery just because I think it's easier. We use less wires that way. But I'm going to put a wire out, and then I'll connect it to my my light like this. Connect another wire, connect it to my light like this, and then connect my wires like so. So this one is in parallel because we have 2 paths that our electricity can go through, and we can see when we light our close our switch that it's flowing this way and this way. All right, so now if we look through, so this says make it look like this, which I just did. Now it says click on the battery and set the voltage to 20. So just like we did before, we're going to click on our battery, set our voltage to 20. Good. Now what's the next step? Select one of the light bulbs and set the resistance to 20. So it doesn't matter which one. I'm going to pick this one in the middle. Resistance goes to 20. Oh, there we go. Resistance goes to 20. What's our next step? Now we have step 5. Close the switch so the electricity can flow through. Our first question, which light bulb is brighter? Why? So let's look. We can see that it's a little hard to tell now, but if I pulled this away a little bit more, we can see that these lines over here are bigger or brighter than these lines over here. And if I pull them kind of back close together, we can even see that these electrons, this current is moving faster through the light bulb on the right than the light bulb on the left. So why is that? Why does that happen? So I just want you guys to try to answer that. And then step 6 says we're going to take our ammeter again and measure the wires in the middle of each light bulb to see. And I'll write down what I measure here and here. So my first current, what I measure over here is 1. What I measure over here is 2. So I see 1 current, 1 amp, and I see 2 amps over there. So I want you to type 1 amp, 2 amps, and then what is the current next to the battery? Ooh, what is the one at the very end? The current next to the battery, either on the top or on the bottom, is our total current. That is equal to 3. That's interesting. So basically what we're saying is that our total current is equal to current 1 plus current 2. The next thing is we're going to use the voltage from the battery and our total current we just found, which we found was 3, to find our total resistance, again using Ohm's law. So we already know our voltage is 20, we know our current is going to be 3. We're going to use the same equation there. Now I want us to use our formula for our parallel circuit. So we know, again, I probably should have wrote it out, given R1 is equal to, we just said it was 20, and R2 is equal to 10. We're going to use our equation that I wrote down above and then do our work. So I probably should have done it like this just because that's the way we've always seen it. So I'm sorry for that. So I think we can solve it from here. And then again, just like before, are the answers from 4 and 5, I should say. Wait. Yeah, 4 and 5 the same. So this should say 4 and 5. Sorry, I have a couple typos. Should they be the same? Are they the same? Why or why not? Then we're going to compare. So which type of series had a higher total resistance? So we had the same light bulbs, right? So this light bulb is 10 ohms, this one's 20, this one's 20 ohms, this one's 10. But which one had a higher total resistance, series or parallel? And which type of circuit had a higher total current? So I just want you to answer by highlighting either one of those. So I hope that helps. I hope that makes sense. If you have any questions though, please let me know.